Well, welcome back from spring break and welcome to week number 11 of CS394R Applied Probability. In this week, we're going to cover one more lecture. We're going to discuss the Poisson process, which is basically the continuous time version of the Bernoulli process that we studied right before spring break. And we're going to spend some time walking through basically the same type of information we did for the Bernoulli process, as well as some practical examples of how you can use the Poisson process to estimate the number of arrivals within some given continuous time span. So with that, we're going to first talk about really just the definition of the Poisson process, and we'll start this out with a quick review of the Poisson random variable, which we discussed way back when in our topic on discrete random variables. After that, we'll go into a little bit more detail as to the definition of the Poisson process and how it can be applied to different situations. We'll then look at the distribution of arrivals and ultimately start looking at the probability mass function and probability density functions associated with the Poisson process, and ultimately how to turn those into real systems that we can use, looking at things like the time of the kth arrival, memorylessness, independence, the fresh start principle. A lot of these terms are probably, again, seeming familiar from when we talked about the Bernoulli process. We'll then look at the distribution of inter-arrival times, and this is really just a brief introduction to the Poisson process. There's actually much more information in your textbook that you can review, but for the purposes of this course, we really just do a quick flyover and introduction to how the Poisson process works. So with that, let's go ahead and get started.